You told the AI your name at the start of the chat. An hour later, it still knows. But tomorrow, completely gone. Welcome to This Explainer. Today we're unpacking a massive headache that anyone who uses large language models has wrestled with: AI memory. We're going to visualize exactly how an AI holds on to info, why it suddenly drops the ball, and how engineers are quite literally rebuilding these systems from the ground up to fix it. To really get this, I want you to picture something super simple: a beautifully clean, empty whiteboard. Because, as you'll see, that whiteboard is the absolute key to understanding both the magic and the totally maddening limitations of AI today.
We've all been there, right? You spend an hour carefully explaining your project, maybe a gnarly coding problem or your specific creative writing style. You're really vibing, building a genuine rapport. But the very next day, you open a fresh chat and you get a total blank stare. It's the ultimate fresh start phenomenon. It forces us to constantly repeat ourselves, and honestly, it begs the question: why can't this incredibly advanced, cutting-edge system just remember who I am?
Well, this brings us to a fantastic visual analogy from a YouTube creator named Product by Kel. He says, and I quote, "Imagine your AI has a whiteboard. Everything it can see lives on that whiteboard." End quote. So when you type out your instructions or paste in a giant file or just have a back and forth chat, all of that text gets written onto this board. But here's the catch, and it's a big one. The second it runs out of physical space, the old stuff, it just gets pushed right off the edges. Poof, the AI literally forgets it ever existed. Okay, so let's get into the technical term for that whiteboard. We call it the context window. And it's super crucial to understand that this context window isn't permanent storage, not at all. It is purely temporary working memory. Research from envisioning.io points out a really important distinction here. See, AI actually has two types of memory. You've got parametric memory. That's the massive amount of world knowledge baked right into the model's actual parameters during its huge training phase. That's how it already knows the capital of France without you having to tell it. But the context window? That's just its short-term memory. It's strictly for right now, for your specific active conversation.
This actually leads to a really fascinating, kind of philosophical point raised in an awesome essay by Kenneth Reitz. Think about human consciousness. It's continuous, right? Even when you aren't actively thinking about a problem, it's simmering away in the background. We carry forward emotional residue, we maintain a persistent state of mind. But the AI mind, it's entirely discrete. Reitz explains that an AI doesn't just sit there thinking between your messages. There's no ongoing stream of consciousness. When you hit enter, a temporary mind literally flickers into existence, reads the entire whiteboard from scratch, guesses the next most probable sequence of words, and then it just vanishes again.
Because the AI has to read that entire whiteboard simultaneously, every single time you send a message, it creates what Ritz calls context gravity. Basically, your early messages have this enormous gravitational pull on the rest of the chat. If you jump in feeling frustrated and demand technical help, the AI immediately adopts this helpful problem-solving persona. But if you start off super philosophical, it stays contemplative. It isn't persisting a personality deep down, it's just looking at the whiteboard and completing the pattern. It's kind of going, okay, the human came to me with a vulnerable tone, I should preserve that dynamic.
So that brings us to section 1, the bottleneck, why bigger whiteboards fail.
You're probably wondering, if the context window is the key to everything, why don't engineers just build an infinitely massive whiteboard and call it a day? Well, the answer lies in a really interesting archive research paper called Lost in the Middle. Researchers wanted to see how well these language models actually use massive context windows. You'd assume if you give an AI a huge document, it can read all of it equally well, right? Nope. Look at the huge performance dip right in the middle of the data. The AI is actually great at recalling info at the very beginning of your prompt, and it's totally solid at the very end. But if the exact answer you need is buried somewhere in the middle of a giant whiteboard, it completely drops the ball.
And honestly, it's not just an attention span problem. It is a massive hardware problem. According to documentation from BentoML, LLMs rely on something called a KV cache, which stands for key value cache. To speed up generating its answers, the AI temporarily stores these complex mathematical representations of every single word or token in your sequence. But here's the rub. As your context window gets bigger, the size of this KV cache just balloons linearly. And that completely exhausts extremely limited, insanely expensive GPU memory. It creates a massive computational traffic jam. You essentially end up tying up millions of dollars worth of hardware just holding on to inactive memory for an idle user. It's just not sustainable.
But here's where the story completely shifts. Some AI tools are now getting longer memories, and that raises interesting questions. Because the industry realized pretty quickly that just brute forcing a larger and larger context window wasn't going to cut it anymore.
They desperately needed a paradigm shift.
Which leads us to Section 2, Beyond the Whiteboard, Building the AI Library. To make AI truly autonomous and, deeply useful, engineers are moving our mental model way beyond that easily erased whiteboard. They're actually building the AI equivalent of a permanent, highly organized, massive library. And the absolute key to this new architecture is something called the vector database. According to a great practical guide from the dev community, traditional databases usually look for exact keyword matches, but an AI needs to retrieve information conceptually. Like if you ask about startup risks, it needs to find passages about revenue drops or maybe legal challenges, even if the actual word risk isn't anywhere in the text. To pull this off, developers use an embedding model to turn text into high-dimensional numerical vectors. It sounds crazy, but basically concepts that are similar in meaning end up physically close together in this mathematical space. Then, systems like ChromaDB store these vectors permanently.
Let's break down how this actually builds into a working system for an AI agent. When you type a new message, step 1 is obviously the input. Instantly, in step 2, the system translates your text into a numerical vector. Then, step 3 is where the magic happens. It dives straight into the vector database to perform what's called a similarity search. It's looking for the most conceptually relevant memories from all of your past interactions. Finally, in step 4, it takes those specific old memories, pastes them right onto today's whiteboard, the context window, and generates a highly informed, totally personalized response. So it doesn't even need an infinite whiteboard anymore because it only pulls out exactly the books it needs from the library. It's brilliant.
Of course, managing a library this complex requires some serious strategy. That dev community article highlights a bunch of advanced patterns engineers are using. Because you can't just save every single hello or thanks, right? That's junk data. So developers use memory summarization to compress long, rambling chats into core facts. They also use hierarchical storage to separate hard, cold facts from casual conversational history. And perhaps most importantly and coolest of all, they actually have to program forgetting mechanisms. Basically, deliberately time-decaying certain information so your AI doesn't hold you to some random opinion you expressed 3 years ago.
And that brings us to Section 3, the implications of persistent memory.
As we conquer these KV cache bottlenecks and deeply integrate vector databases, the AI we interact with every day is rapidly transforming. It's going from a discrete amnesiac tool into a persistent long-term digital partner. And man, that shifts the conversation entirely. Because once an AI can maintain an ongoing state, actually remembering your preferences, your anxieties, your coding style, and just the context of your life over years, it ceases to be just software. It kind of becomes a reflection of who you are. The technology to make this happen isn't sci-fi. It's already being deployed right now. The whiteboards are no longer being wiped clean at the end of the day. So as we wrap up this explainer, I really want to leave you with this final, absolutely crucial thought. What would you want AI to remember about you? And what would you want it to forget?